Okay, moles. Moles are basically the measuring unit for counting particles, specifically using the Avogadro's number, which is 1 mole is equal to 6.02 times 10 to the 23 power. This is the Avogadro's number. This applies to basically atoms, molecules, and formula units, which I will discuss in a bit. The entire point of mole existing is because since atoms are too small to count directly, moles connect microscopic particles to measurable mass. Now, to make this a more easier understanding, we need to understand the types of particles. Atoms, let's put atoms here, are basically basic units of an element. Think of oxygen, which is O, and H. Those are just atoms. Molecule, on the other hand, are covalent bonded, uh, two or more atoms that are covalently bonded. So basically, think of water, which is H2O, or O2, which is a diatomic. It's also called oxygen. Now, lastly, formula unit. We put formula unit here. Formula units are just small. It's the smallest whole number ratio of ions in an ionic compound. Basically, like, um, basically think of a ionic compound like sodium and chlorine, which is called sodium chloride. And this basically tells us that one atom of sodium corresponds to one atom of chlorine because of the, oh sorry, not atom, but one ion of sodium has one atom of chlorine because that is their charges. If you don't know their charge, it's positive 1 and negative 1. This is formula units. Now, since we understand the particles and we finally understand moles, we need to understand the most one of the most important things, which is called molar mass. Molar mass are basically found um molar mass basically is just how much mass is in one one mole of an element or compound. But to make this easier, to find the molar mass, let's say hydrogen. It's already in the periodic table. You'll see the number below the letter, which is 1.008 for hydrogen. This is the molar mass of that element. And depending on how many elements there are, like H2, if there's H2, you should multiply the molar mass by 2. And if there's another element like oxygen, you also add the molar mass of oxygen to the hydrogen. Now, the reason why we needed to learn molar mass, moles, Avogadro number, is to understand the conversions because it's the most fundamental thing to learn while doing stoichiometry. Mole, to make this more easier, I'll make a diagram which is mole on the top here, uh, arrows here, is there, no number of particles, and over here is the mass of the element, which is grams. Okay, from starting to moles to number of particles, So to understand how many, what do we need to do? Mole, to get the number of particles by using mole, we need to multiply the mole with the Avogadro numbers, which is 6.02 times 10 to the 23 power to get the number of particles. But if we're getting the mole, if we have the given, if we have number of particles, we divide the number of particles to 6.02, which is the Avogadro number as well, to get the mole. However, when we're getting the mass of the mole, we need to multiply the mole with the molar mass of the given element. So it's just multiply by molar mass, and the mass, to get the mole, we need to multiply the mass with the molar mass. I'll give a quick example real quick so we can I can easily explain this to you. Now, let's say we have 2 moles of hydrogen, or just H2. To get the number of particles, we need to multiply 2 moles of H times 1 mole. Wait, no. The Avogadro numbers, remember, Avogadro number is this 6.02 times 10 to the 23 power particles over 1 mole of H. Just basically tells us that every mole of H we get 6.02 times 10 to the 23 particles of H. So we need to cancel it out. We'll cancel out the moles of H and the particles stay. So 2 times 6.03, well, no, 0.02 times 10 to the 23 power, we get 1.204 times 10 to the 24th power, and since it's just divided by 1, it doesn't change anything. So as we get the answer, which is this, we put particles of H, wait, no, of 2 moles of H. So it just tells us that there are 1.204 times 10 to the 24th particles of H from 2 moles of H. So now we got the number of particles. Now let's try to get the mass of 2 moles of H. So we need to get the molar mass. The molar mass is 1.008 of 1 hydrogen, but since there's 2 moles of hydrogen, we need to multiply 1.008 times 2, which is 1.008 times 2. It becomes 2.016 grams per mole, because that is the, oh, uh sorry, uh 2.016 grams per mole, because that's the molar mass unit of H. Oops. Of H. So let's put H2. So we got that, right? So now we multiply the mole with the molar mass. Let me just remove this. Let me move up here. Whoops. Let me move this up here. And we need to multiply this. We need to put 2 moles, since we're going to use scientific solution of H is equals to 2.016 grams over um 1 mole of H2. H2 is the same with 2 moles of H because it's just two hydrogens. It just makes it more simpler for us. So, and it is the correct way. So we cancel out mole and mole. Now we multiply 2 times 2.016. We get 4.032 grams. We also cancel out the mole up here. Since we cancel everything here, cancel the mole, cancel this mole, and cancel this mole, so we only get the grams. So it multiplies with everything here. So 4.032 grams of hydrogen, 2 moles of hydrogen.